Hello and welcome back. We are going to continue our discussion about factoring. And to get us started today, since we are jumping into section 6.2, which is factoring trinomials, to get us started, I just wanted to do a quick recap. And that quick little recap takes us back to a problem that we had in our previous lecture. If we were to look at this polynomial, the first thing that you want to do whenever you're looking at factoring is see if there is something common between all terms. And if you're looking at something common, you would be looking for a GCF, or greatest common factor. This particular problem does not have any greatest common factor because all of these terms are not divisible by the same thing, and you don't have the same variables throughout, at least one consistently. So if you were to encounter this kind of problem, it's a four-term polynomial. You can see that you have four separate terms. You can't really factor it using a GCF because there's no GCF here, but you do have to factor by grouping, meaning it's a four-term polynomial. You split it in half like Math Ninja, as we discussed last time, and you would go through this process. You'd look at the first half. You can pull out an m. You're left with 6m minus 5n. The second half, there's no common term that you can pull out, so you can pull out 1. This is already positive, so we're pulling out a positive 1. We don't want to change any signs here. And you're left with 6m minus 5n. Now, from here, you could easily pull out your 6m minus 5n, which is your common binomial here, now your GCF, if you will. And then you're left with m plus 1 as your end result. So this is your factored form, and that works beautifully for a four-term polynomial. However, today's lecture, we're jumping into a three-term polynomial. So for example, if I were to have a problem such as x squared plus 4x minus 12, I would look at this problem first and say, do I have a greatest common factor between all of my terms? There's no coefficient here, so it's implied as 1. I have 4 and 12, so nothing that's divisible between all of these. And I don't have an x, at least one x, on all of these terms. So there's no greatest common factor. Is it a four-term polynomial? No. It's a trinomial. It's a three-term polynomial. So I can't play Fruit Ninja with this, or sorry, Math Ninja. I can't play Math Ninja with this. So what do I do? So just to give you an idea, what we're going to do is one of three different methods, and I'm going to explain these methods as we go throughout the rest of this lecture component. What we're looking at is factoring trinomials. There's three different methods. As they start getting progressively harder, we'll talk about each new method. You probably do want to know why I have something written over here on the side, though. So before we get into factoring, what I'd like to do is point out that you do want to have your factoring rules set on a separate piece of paper, kind of like what you did with exponent rules a few lectures back. You want to set these off to the side so that way you have them as a quick reference. The first thing is always, always, always check for a greatest common factor. If there is a greatest common factor, pull it out first. That is the first thing you want to do when you're looking at factoring. The second thing is, and this will really start to depend on what kind of polynomial you're looking at, but it's a process. Think of it in order. If you're dealing with a four-term polynomial, you can factor by grouping like we did with this example. However, adding to this, rule number 3, if you're dealing with a three-term polynomial, so if 3 terms, then you have to factor by one of 3 different methods. The first method I'm going to show you is the box method, and it's the same as the guess and check, or guess and check. We're going to be all hip and cool and just use the N, like steak and shake, but guess and check. Yeah. All right, that being said, we're going to go into box method first. Now, the box method works like this. I create a box. Kind of looks like an upside down pan. I have a little handle out here to the side. Inside of my box, I have 4 sections. Now, looking at my 4 sections, what I'm actually going to do is create values in here that will then give me my corresponding values. So let me show you. My first term of my polynomial, of my trinomial, will go right here at the very bottom. My last term of the trinomial will go right here next to it. So it's kind of looking out of order now, but that's okay. This middle term goes over here at the very end, so that becomes 4x. So keep your signs together. Now, here's how the box actually works. This is the setup, so that's what we're looking at. That's everything that you need to set up. Vertically, within the box, you have to multiply these terms to get your bottom value. So in this case, what times what gives you x squared? This would be x and x. So x times x does give me x squared. Awesome. We'll come back to the sign. What times what can give you 12? I have 1 and 12, 2 and 6, 3 and 4. So I have a couple options, right? But here's what I want to do. I'm considering that my end result over here is 4x. So I want to know what pairs of numbers will give me 4, potentially. So out of 1 and 12, 1 plus 12 would be 13, 12 minus 1 would be 11, and you have positive and negative variations thereof. So it's like, that's not going to work. What about 2 and 6? 2 plus 6 is 8. That's not going to work, but 6 minus 2 is 4. That could work. So I'm going to say 2 and 6. Now, does 2 times 6 give me 12? Absolutely. We'll come back to the sign, so don't worry about that just yet. Looking at my 4x, here's how I'm going to get my 4x, and I'm going to use a different color just to give you some clarity here. This is my purple marker, so hopefully it shows up nice and purple. But I'm going to multiply in this direction. So it's kind of like a cross multiplication within the box and spitting the answer out. So x times 2, that gives me 2x. I'm going to use my blue marker now. Crossing this way, I have x times 6, gives me 6x. Now, we were playing with some values just a moment ago when we were talking about how we would get 12. And so we said 2 times 6, yeah, that does give us 12. And then we said that the 6 minus the 2 would give us 4. So how would you get positive 4 from these two values? Well, 6 minus the 2, right? So 6 is positive, 2 has to be negative. So that's going to be a negative 2, which means that this is a negative value in here. We said that 6 is positive, and so that would be a positive 6 in here. Okay, so let's just check ourselves one more time. Does negative 2 and positive 6 give me positive 4? Absolutely. Does negative 2 times positive 6 give me a negative 12? Yes, absolutely. And x times x is x squared. So my box is now checking out. I can find all of these values from the box. And what that means is if I read this box line by line, left to right, so I'm reading left to right, I have x minus 2, x plus 6. And this is my factored form of that problem. So I have x minus 2 times x plus 6, and that is the factored form. This is the box method. So the box method is not for everyone. I will tell you that now, and it does take practice. So I will do a couple more with box method just to be clear on how that works. However, the box method is one of those methods that's considered to be really an organization. So mathematically, it's more of just organizing your thoughts as you go through the process. But let me show you another method, which is called the guess and check method. And some people will prefer box over guess and check. Some people will prefer guess and check over box. It's really a matter of preference. And some problems will lend themselves a little bit more easily to one method or the other. Now, for this problem, I think it's personally, for me, easier to just do it in a guess and check method. And I'm actually going to put my original problem down here. So x squared plus 4x minus 12. I'm going to set up two sets of parentheses. So guess and check, I don't have a box or anything like that. There's no organized system to it. It's really guessing a value and checking that value. So the first thing that you have to understand about guess and check is you're really looking at the process of FOIL, but backwards. So you're unfoiled if you think about it that way. Okay. Now, the question is, from the first term, you know that the first term, while your trinomial is in descending order, which it is, you know that the first term here comes from the multiplication of your first terms of the binomials. So what times what gives you x squared? Well, that's x and x. So that definitely checks out. Now, the last value comes from these last values of the binomial. So this term is also obtained through multiplication. This term is not obtained through multiplication per se. This term is actually a combination of two different terms. But let's go ahead and look at 12. So 12, you have a couple different options. You have 1 times 12, 2 times 6, 3 times 4. We just solved this problem, so we know it's 2 times 6. So we're going to use 2 and 6. This is where it comes into play. 2 times 6 does check out. It gives you 12. Notice I haven't put any signs just yet. Now, here's what you need to do as part of your guess and check. This is where it helps to write it down. This gives you 2x. This gives you 6x. Okay. Now from 2x and 6x, how do you get a positive 4x? 2 has to be negative. So that means that's negative, which means this is positive. Now, don't stop. Negative 2 times a positive 6, does that give you a negative 12? Yes. So that checks out, and it works across the board. Now, in this guess and check method, you're doing the same exact thing as the box. The same exact thing. The only difference is the box is helping you to organize your thoughts as you're jotting notes down. So if you have to do a lot of processing here because maybe the numbers are much larger, you have different combinations or more combinations, then what you might want to do is utilize the box and just see how it works for you. Guess and check is fairly easy, especially with this kind of problem, but it does take a little bit more mental processing because you're not jotting your notes down. Instead, you're kind of doing it in your head, if you will. Okay? Now, that being said, there's another thing that you need to understand here, and that is with the guess and check method, there are two very key components that you must understand, and these are the signs. So I'm going to start with this sign. I'm using my blue marker to make the note. Oh, and I think I just lost power in the building. Hold that thought. Hi, I'm sorry about that small little blip right there. We just had a small power fluctuation in the building, but that is okay. We're going to jump right back in because my recording did not get cut, although it is cut in your video. So that being said, the two components that you have to focus on whenever you're doing guess and check is that you must pay attention to the signs. I'm going to use my blue marker for the first note. You have to interpret this last sign first. So as you're looking at this last sign, it is negative, And so if this last sign of your trinomial is negative, so if negative, I'm just using a little negative sign and circling it. If negative, then signs of the binomial pair or binomials are opposite. So if your sign here is negative, what that's saying is that the signs in your binomials are opposite, which they are indeed opposite here. Okay, excellent. What if that sign were positive? If the sign was positive, the signs of the binomials are the same. So if this were a positive sign, it is not in this problem, but if it were a positive sign, that means that both of these binomials would have the same exact sign, either both positive or both negative. The question is, which one's which? And that's where it comes over to this sign. So I'm using my purple marker now. For this sign, this is what I like to call the determining sign. It's not an official name. Determining sign. Here's how it works. This sign is going to always go to the greater of the two terms through multiplication. I have to stress that because as you start getting a little bit more complex with the values, that comes back into play. But for right now, you can see that 6 is greater of these two. So what I'm looking at is that this sign is attached to the greater of these values. So notice that through multiplication, this was 6x, this was 2x, hence we have our little note here. The greater of these is 6x, hence this term gets the positive sign. Excellent. This sign was opposite because this was negative. So the determining sign goes to whichever is greatest. Now, that being said, that is all there is to really understanding how to factor trinomials. So we're going to do a few examples. And as we start getting into the next method, meaning the problems get a little more complex, we'll discuss the AC method a little bit later. So let's do a couple problems, which means I need a little board space. I'm going to leave this up for right now, just as a little quick reference. But I will put a dividing line here just so I know where my boundary is. Okay, so we have our first problem. Our first problem I have as x squared plus 4x. Oh, I'm reading the wrong problem. I'm reading that problem. I have x squared plus 6xy, that looks better, plus 8y squared. And it says, for all of these examples, factor completely. So what I'm going to do is I'm actually going to take this problem and I'm going to factor using both the box and the guess and check. So I'm going to do both methods. Again, you pick the method that works best for you. I'm going to start with guess and check. So I'm looking at this setup. I set my parentheses. My first term is through multiplication, so that's what times what gives me x squared. I'm going to say x and x. My 8y squared is a little more complicated. It still comes from multiplication, so what times what can give me 8y squared? Well, I definitely know the y is y times y. Fairly certain of that. Now, 8, I have 1 and 8, and I also have 2 and 4. So the question that I'm going to help to resolve this is what from those pairs could give me possibly a 6? Well, not 1 and 8, but 2 and 4 could. So I'm going to try 2 and 4. It doesn't matter on which one is where at the moment. You can always get that from guessing and checking, and then if it doesn't work, maybe flip it around and see what happens. All right, but here we are. I have my values. So this is 2xy. This is 4xy. I'm multiplying those out. From 2xy and 4xy, how do I get a positive 6xy? Both of these must be positive. So plus and plus. Let's ask ourselves, 2y times 4y, both of them being positive, does that give me 8y squared? Yeah, sure, absolutely. It does add up. We just did that here. Now, let's go with the interpretation of signs. Let's just see how that works, because I know that's a relatively new concept for some of you. So I want you to really kind of get into the habit of interpreting those signs. My signs of the binomials should be the same. They are. And because the signs of the binomials are the same, well, they're both going to be positive. Because remember, this determining sign goes to the greater term, but if the signs are the same, they're both going to be whatever that sign is. And that means positive in this case. Okay, very good. Now, same exact problem, but I will do the box method for those of you who are more interested in the box method. So I got my box, set it up nice and large. Got my 4 quadrants in here. I got a little side out here. Remember, my terms, I need to set them up so that they are underneath the box. First term goes here. The last term goes right next to it. And the middle term goes outside of the box. What times what can give me x squared? That's x and x. What times what can give me 8y squared? Again, I'm fairly certain on that y. So the question is, what times what could give me 8? 1 and 8, of course, 2 and 4. So I'm going to use 2 and 4 because that can possibly give me 6. I have 2, I have 4. Cross multiply here. So I have x times 2y gives me 2xy. I have x times 4y is 4xy. How do I get positive 6xy? I add both of those up, meaning they are both positive. Therefore, because these are both positive, from left to right as I read this box, I have x plus 2y. It might help if I could write. So x plus 2y, x plus 4y. And that is it. Now notice, these are exactly the same. So either method will work for you. It's a matter of preference. Sometimes I get the question of, hey, what happens if I got x plus 4y over here, x plus 2y over here? Is that different? No. Again, you can multiply in any order. So all you're doing is changing your order of multiplication there. But again, either way, guess and check or box, both will work, providing the problem is factorable. Okay, let's do another problem. Factoring takes lots and lots of practice, so please, please, please put in the work to get that extra practice in there. So, next problem I have is a to the 4th minus 4a to the 4th minus 4a squared. I have no idea what I was just writing there, but it is on the paper this way. A to the 4th minus 4a squared minus 21. I'm going to leave this one up to you, either box or AC. It's really up to you. I am going to use just the AC method at this point until we encounter the AC method a little bit later. So for now, I'm just using guess and check. So guess and check, got my 2 boxes, or my 2 parentheses, I should say. What times what could give me a to the 4th? Ooh, I have a couple combinations there, but think of the one that splits down evenly. So I have a squared and a squared. What times what could give me 21? 1 and 21, 3 and 7. Hey, 3 and 7 might give me 4. Let's try it. I have 3, I have 7. I'm now going to interpret my signs to show you how I can use the interpretation to actually get my signage. So my signs will be opposite. I know they will be opposite. And I know that the greater term should be negative. So what's greater, 3a squared or 7a squared? 7a squared. So that's going to be my negative. That's positive. And that's it. Can you check yourself? Absolutely. FOIL it back out. See what you get. You should get the original problem. Let's try another one. Now, so far, as we've been tackling these problems, I've been focusing solely on the methods of either box or guess and check. I've been really hammering those in because those are what we were trying to develop as a skill. But now we're going to take a step back and look at the holistic picture, the bigger picture, if you will, and we're going to go back to all of our factoring rules. So, step one, is there a GCF? Yes, they all have an X. That's pretty obvious right off the bat. They also are all divisible by 3. So let's pull out 3x. Now, that leaves me x squared minus 4x minus 12. Now, what am I left with? Again, I have that 3x. We'll just circle it and bring it down. We know it's going to be something that's used later. Is this factorable? Well, it's not 4 terms, but it is 3 terms, which means I could use box or guess and check. I'm going to use guess and check just because. What times what gives me x squared? I have x and x. I have 12. 1 and 12, 2 and 6, 3 and 4. Hey, 2 and 6 might give me 4, so I'm going to use 2 and 6. My signs will be opposite, I know this, and the greater term will be negative. So that's 6x, that's 2x. This one will be negative. This one will be positive. I still have my 3x. And I am factored. Excellent. Okay. Let's try another one. I have 6q minus 27 plus q squared. This one looks a little different. So I'm looking at my other problems here just to kind of go back and reference my notes a little bit, and you got some other problems on here as well. These are in descending order. Even when I factored this one out, it was still in descending order. But that one's not. So the first thing you want to do is put that into descending order, because it's not in a format that you can really do any factoring with anyways. So put it in descending order and then re-evaluate that problem. So you have q squared plus 6q minus 27. Okay. Do I have a GCF? No. Is it 4 terms? No. Is it 3 terms? Yes. I can use box or guess and check. So let's go ahead and use that guess and check. Q times Q would give me Q squared. 27. I've got a couple things for 27. 1 and 27, and then I got 3 and 9. Hey, 3 and 9. Let's use that. So 3, 9, again, doesn't matter where I'm putting them. If it doesn't work out, you could always go back and flip them around. Now, in this case, I know my signs are going to be opposite. This is going to have to be a negative, so I know this to be opposite in my binomial. My greater term is going to be positive. So this is 3q, this is 9q. Hey, that's my positive one. Because the signs are opposite, that's negative. Okay. Now, that is it for section 6.2. I'm actually going to also roll in section 6.3 to this lecture So that way we can get through all of our trinomials, and you can see that last method as well. So I'm going to show you the AC method at this point. And it's just a little step up, if you will, from what we've been working with. But let's say I have 3x squared plus 11x plus 6. So I have 3x squared plus 11x plus 6. Notice something different here. There's no GCF. It's in descending order. It's a 3-term polynomial. But that lead term has a coefficient. What? What does that mean for me? I've been dealing with lead terms that have no coefficient, or technically a coefficient of 1. So what do I do here? Could I use box? Yeah, absolutely. Could I use guess and check? Guess and check. Yeah, absolutely. But for any of these that start to get much larger than 3, I suggest using another method. And that other method is called the AC method. So I'm going to put that over here. And the AC method will work every single time. However, but providing it's factorable, it will work every single time, providing it's factorable. That being said, the AC method is sometimes overkill. And so you don't want to just rely on using the AC method every single time, because it might be wasting more of your time than what you really need. Now, if you need one set method that you can do every single time and you don't care about going a little bit longer on something, that's okay. Use the AC method, jump right into it, and take care of that baby. Now, in this example, I think AC is a little overkill, but we're going to do it anyways because I want to show you the process. Now, to understand the AC method, you have to understand what we call the standard form. And so the standard form for a trinomial is going to be ax squared plus bx plus c. And I wrote it directly underneath, so that way you can see that we have a being the coefficient value, b being a coefficient value, and c being a constant value here. We are in descending order. The AC method comes from multiplying a and c from here. So the AC method is quite literally a times c to get some value. So in this case, we're going to say a is 3 times 6 is 18. Now, how does that help me? 18 can factor down, and it factors down into things like 1 and 18, 2 and 9, 3 and 6. And so we're looking at these pairs of numbers and asking ourselves, what from those pairs of numbers, either through addition or subtraction, will give me this middle number from the original problem? 1 and 18, added and subtracted, you get either 17 or 19. 2 and 9, you get either 7 or 11. Hey, you needed 11. So I'm going to use 2 and 9. All right, how does that help me? Check this out. That middle term is about to be split up. So I have 3x squared, nothing's changed there. That 11x is going to be 2x and 9x. I did not put signs yet. And then plus 6 at the end. Now, there's a very clear reason why I did not put signs. And the reason for that is I need to determine if these will actually work as numerical values. So here's what I'm looking at. I have 2x, I have 9x. From those two terms, how do I get a positive 11x? Well, both of these have to be positive. Okay. Now, let's reevaluate. Where am I at? Now I have a 4-term polynomial. You know how to factor a 4-term polynomial. It's factoring by grouping. You already have a rule for that. So this is where you play Math Ninja. Looking at the first half, I have x in common, so I can pull that out. I'm left with 3x plus 2. Looking at the second half, I don't have anything that I want to change as far as sign, so I'm going to have a plus. I have 3 in common between these two, so I can pull out a 3. I'm left with 3x plus 2. Pull out this 3x plus 2. I'm left with x plus 3. And there you are. That is your factored form using the AC method. Now the AC method is absolutely wonderful. Again, for any values 3 or higher. If this is a 2 for your leading term, I would really just stick with guess and check or even the box method. But 3 or higher, this is really, really great to use for any of those terms. Now, let's do a couple more practices just so we can get situated with the AC method. So I have 8x squared minus 22x plus 5. Always go back. Is there a GCF? No. Is it 4 terms? No. Is it 3 terms? Yes. This lead term is greater than 3, so I'm going to jump into AC method. That's just my drop-down rationale, if you will, as I'm going through those factoring rules. So I'm going to take AC, so 8 times 5, that's my A and my C. That gives me 40. And I want factor pairs of 40. That will give me 22. Well, hey, sounds like 2 and 20 to me. Let's check it. So I have 8x squared, 2x, 20x, plus 5. What signs do I need here to get a negative 22? Well, negative and negative. Okay. Math Ninja. Now I'm looking at this. I can pull out a 2x from both of these. That leaves me 4 minus 1. Over here, I want a sign change, so I'm going to pull out a negative. 5 goes into both of these. That leaves me 4x minus 1. Remember, you had a sign change, so make sure you change it. I can pull out, oh, that's a 4x. Obviously, I wasn't watching as I was stating it. I can pull out my 4x minus 1 now. And then I have 2x minus 5 left over. It's a little bit easier than guess and check, in my opinion, because 8, you have a couple combinations. 5, you really don't. So guess and check would have been okay on this problem, but if that weren't a 5, if it were something that had multiple pairs, this method would help save a lot of time as opposed to guessing and checking. All right, AC method is wonderful. I absolutely love it. It's another great way to visually see how you're working through a problem. Let's try this next one. 4x squared minus x minus 5. Now, in this particular problem, some of you might be saying, guess and check. I can see that quickly. You're absolutely right, and you can absolutely go for it. However, I'm going to use AC method still because I want to show how that works. Now, in this case, A and C, so 4 times 5, that gives me 20. Notice something. I didn't say negative 5. I just did the numbers, 4 times 5, and that gave me 20. I'm interested in my pairs from 20. That might give me a 1. Well, 4 and 5 are great for that, so I'm going to use them. So I have 4x squared, 4x, 5x, minus 5. From 4x and 5x, how do I get a negative 1? I have to have a positive 4 and a negative 5. Quite curious. It's a little bit different than what we've seen so far, where the signs matched up and you could easily see those numbers very quickly. Okay, split it in half, Math Ninja. First half, I can pull out a 4x. That leaves me x plus 1. Second half, I can pull out, I want a sign change, so I'm pulling that negative. I can pull out 5 from both, and that leaves me x plus 1. That leaves me x plus 1 times 4x minus 5. Interesting. Because notice in my previous problems, I've come out to signs that are the same, but my signs here are different. Let's go back to interpreting our signs. Are my signs supposed to be different? Yeah, absolutely, they are. Are my signs supposed to go, or is my negative supposed to go to the greater term? Yeah, it should. So let's see. This is 4x. That would be 5x. That's my negative. So you can still use guess and check here. And of course, you can always multiply this back out to get the original problem. But AC method, again, works every single time, providing the problem is factorable. Let's try another one. I have 24x to the fourth plus 40x cubed plus 6x squared. And you might be looking at this like, oh no, that looks terrible. What do I do? Help me, Obi-Wan Kenobi. You're my only hope. All right. It's not that bad. Go back to your factoring rules. Rule number 1, is there a GCF? Yes. So I see these are all even. So I know I can definitely at least pull 2. Can I pull anything else? Yeah, I can pull an x. 2 of them, in fact. So I'm going to pull out 2x squared. What does that leave me with? 12x squared plus 20x plus 3. Still not like great looking, but at the same time, not as bad as it was before. So we're going to circle this, bring it down. We'll come back to it later. Let's look at this part. 12 times 3, I'm jumping into the AC method because it is a trinomial. So I'm using AC. That gives me 36. Factor pairs of 36 that might give me 20. How about 2 and 18? Okay. So that being said, I have 12x squared, 2x, 18x, plus 3. I needed a positive, I'm going here. I needed a positive 20, so those have to be both positive to be able to give me that. Play some Math Ninja. First half, I can pull out a 2x. I'm left with 6x plus 1. Over here, I don't want a sign change, so plus. I can pull out 3, and I'm left with 6x plus 1. Combine those, I can pull out 6x plus 1. I have 2x plus 3. And then, hey, I see an arrow. That's 2x squared on the outside. Not too bad, right? AC method is really, really helpful, especially as those terms start to get larger. Now, there are a couple other situations which are known as perfect square trinomials. Perfect square trinomials have definitions, and you've already seen these definitions, actually. So you might remember from a few lectures back, we talked about two identical binomials being multiplied. And it looked something like this. We had x plus y squared, meaning two identical binomials being multiplied here, because that would be expanded to x plus y times x plus y. And it would give you this situation right here. We have x squared plus 2xy plus y squared. So it was a definition value. Likewise, you had the subtraction version or the difference version, just like so. Now, these perfect square trinomials really help you in understanding how to factor if you're just using the definition. So if you're able to quickly identify something such as the problem that I'm going to give you here, this is 25x squared minus 20xy plus 4y squared. You might be looking at that like, oh man, do I have to really go into those? No, you really don't. You could go right into a perfect square trinomial rule. Now, in doing so, I see that I am in descending order of x, because I have multiple variables, so I'm in descending order of x. I see that my terms are squared on both ends, hence a perfect square. And I notice that this middle term looks like it would be the product of the factors on either end. So let's just see what that looks like. So I should come up to, I'm just going into guess and check for this. I should come up to 5x, 5x, 2y, 2y, and I'm going to say subtraction for both. Why? Signs are the same, meaning they're both going to be negative here. Does that work out? Well, 5x times 5x is 25x squared. 2y and 2y is going to be 4y squared. It doesn't matter that they're both negative because negative and negative makes that positive. This gives me 10xy, negative 10xy. This gives me negative 10xy, so that does work as well once I combine those terms. That also means that because this is identical to this, that I have 5x minus 2y squared. Now, if you saw this in the definition automatically, you could just go straight to this little response and skip the factoring step. If you did not see that, don't worry. All of these rules that we've just talked about for factoring methods and trinomials still apply. You can still use them. It's just if you have the definition, you can use it too. Okay, let's try one last one to conclude this section. Looks like I have a perfect square on the front and back ends here. So I'm just curious, what would happen if I don't know, split that up? And I said 6n squared, 6n squared. 1 is always nice, 1 times 1. Signs will be the same, and they're both going to be positive. Does that work? Well, I know these multiply out because I've already done that. This gives me 6n squared times 1 is 6n squared, plus another 6n squared. Yeah, that works out. So this is going to be 6n squared plus 1 as a quantity squared. Don't forget to simplify to this last step right here, because what you're looking at is the same binomials, and you have to get that accounted for. And it looks like my lights just turned back on because we had a power outage. Okay, that being said, that concludes this section for us. Let there be light at the end. That being said, yes, this does conclude our section, and we will jump into section 6.4 in another lecture.